Broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Happy Thursday, and thanks for joining us for this morning's webinar, Leak Detection and Methane Reduction. I'm Marissa Davis, and I'll be facilitating for you. So today we'll have our regulatory guys on the line to discuss the requirements for pipeline operators to update their inspection and maintenance plans to address the elimination of hazardous leaks and minimize the releases of natural gas from their pipeline facilities by December 27th of this year. We'll save questions for the end of the webinar, so if you have one, please submit them through the question box here in GoToWebinar, and they will be happy to answer them afterwards. The host of today's webinar, G2 Solutions, provides responsive support in a comprehensive suite of asset integrity, engineering, GIS, field services, regulatory, and technology solutions that address asset performance through its life cycle. If you'd like to learn more about our services, visit our website at www.g2-is.com. Sorry, it seems like I have a little bit of feedback here, but right now I'll introduce you to our presenters. First up, we have G2's Manager of Regulatory Compliance, Al Giordano. Al is a licensed PE with several years of experience in the industry and a focus on DOT, regulatory compliance, regulatory audits, project management, and integrity management. Al has also served as a PHMSA inspector as well as a marine compliance inspector for the United States Coast Guard. And then we have Wally McGaughey, who is G2's Director of Regulatory Compliance. He has over 40 years experience in the energy industry and specializes in consulting, inspections, audit support, and training. Wally is retired from the PHMSA Office of Training and Qualifications, and he is a frequent lecturer at state pipeline safety seminars, as well as various industry organization functions. So with that, I will hand it over to you guys.
Thanks, Marissa. Good morning, everyone. So today we're going to discuss the recent promulgation that came out of the Pipes Act of 2020 regarding the elimination of hazardous leaks and minimizing releases of natural gas. So to start, the Pipes Act of 2020 included a self-executing mandate in Section 114, which required operators to update their inspection and maintenance plans, or O&M procedures, to address the elimination of hazardous leaks and to minimize any releases of natural gas from their pipeline facilities. Now, this does include intentional venting of gas during normal operations, and so it's not just focused around leaks, unanticipated leaks. And so operators need to be aware that any release of natural gas is affected by this mandate. So the crux of the argument is that operators have to revise their plans to account for minimizing any of these releases from both the design and a materials standpoint, as well as past operating history. Operators should look to revise their plans to address replacement or remediation of these facilities that are known to leak based on these requirements. And the biggest thing is that the statute requires pipeline operators to do this by December 27th of this year. So by the end of this calendar year, operators should have updated their plans and procedures to account for these different leaks and releases of natural gas. So let's talk about leaks for a little bit. Leaks including intentional venting, which is typically refers to a process where natural gas is released into the atmosphere during a normal operations, such as a blowdown or relief valve operation. This also includes such things as compressor stations, such things as regulators on house lines, overpressure protection, and so operators need to take these into consideration as well. Operators should also look to identify if they have any pipeline materials on their assets that are known to leak, things like cast iron, unprotected steel, wrought iron, or any sort of historic plastics with known issues, and that they need to take into account leaks that may occur in an abnormal or normal operation from pipelines with those type of materials on them. And additionally, pipeline operators need to look at leak classification. So most operators have leak grading systems. They determine how bad a leak is and how quickly they need to fix it based on how much gas is being emitted. Should they, keep their existing leak classification limits intact? Should they consider an accelerated repair program? Do they need to repair all leaks? And so the key here is that operators need to update their procedures based on their specific assets. This is not a point where operators should be taking an off-the-shelf approach to updating their procedures. They shouldn't just put in their procedure, yes, we're going to fix all our leaks and call it a day. Now, if an operator does that, then they're going to be held to that standard. Putting code language into the procedures is not what PHMSA is intended here. It's not what Congress has intended. Operators should really be looking at coming up with a dedicated plan based on the specificities of their system to address the different kinds of leaks. So we talked a little bit about leaks, just a little bit more. So, we see some cast iron pipe there, continuous leaks. We know we still have some cast iron pipe in the ground, and we know that cast iron pipe tends to have leaks over time. Operators should be looking at different fittings. Do they have third-party damages? Aging pipe, again, we mentioned that already. Do you have older pipe, cast iron pipe, or other pipe that has the potential for leaking? Curve valves, meter sets, anywhere where gas is normally released. Valve packing, so operators may look at all of their above ground valves to determine if they have leaks on those valves based on the packing. Sometimes the packing wears out and you don't get that seal anymore. So again, these are all things that operators should be taking into consideration when they're looking to update their plans and procedures. And then again, we talked about the equipment, the continuous release, normal operations, compressors, pipeline telemetry, recap systems for compressor drivers, and then any other energy sources where methane may be used or methane may be released into the atmosphere. And so again, I just want to reiterate that it is critical for operators to not take a general tack when it comes to updating their procedures to comply with this mandate. PHMSA, the states will be looking for a tailored approach to identify what works best for your system, looking to see if the operator has put the effort into evaluating their system as an entirety and coming up with modifications to their plans and procedures that fit their system. And so that's just a general overview of kind of what the mandate covered. So what I'm going to do now is I'm going to hand it over to Wally. Wally's going to discuss a little bit further about what operators can do to come into compliance.
Thanks, Al. And welcome, everyone. Thank you so much for joining with us this morning for this opportunity to discuss this emerging topic that's hitting the industry. Attended several public meetings over the last several months since this mandate came out, the self-executing mandate came out. And in some of those meetings, there was information disclosed from different sources. One was the Environmental Defense Fund. And I understand this is something that they have published, and it's something that's being used and looked at by our agencies in the federal government for reducing methane emissions in the United States. Their statements are that methane is the culprit contributing to climate change. It is the biggest factor at this point. It's 87 times more warming in its capabilities than carbon dioxide over a 20-year period, and 36 times greater over a 100-year period. And in their assessment of the measurements that they have taken and using the technology that they have at their disposal, the oil and gas sector is the largest contributor to the release of methane. Granted, there are many other forces out there, and there are many other areas where methane is released into the atmosphere, some naturally, most certainly. So, oil and gas is not the only contributor to this effort, but oil and gas is being singled out as the largest contributor by folks that are pointing this information up to the federal government. A rapid full-scale effort to reduce those methane emissions could slow the worldwide rate, is their stance, by as much as 30%. but a more go slow approach, which would be a longer term solution for this issue, would take only a 5% increase in the total warming trend of the world. So with an accelerated rate, you can reduce that warming by as much as 30%. With a go slow approach, they propose that information as being something that will cause a continued increase, but a slower increase. Some of the biggest challenges being faced by the industry today is methane detectors and what their capabilities are, what we can accomplish with those methane detectors. There's a variety of different types out there. In the presentation that the Environmental Defense Fund gave, they talked about several different ways that they're using things out there, and some of the entrepreneurs that are moving forward with some of this information, some of the companies that are out there on the forefront of this effort. The one thing that they did point out in their discussion was that there's a company that they are a subsidiary with, and the company's name is Methane SAT LLC. And this organization is going to be launching a satellite in 2022 that will have full capabilities of detecting methane plumes on the surface of the Earth. So not only are they pointing out the statistical information that's out there, but they're also pointing out to industry and government that they are going to be a force for monitoring methane emissions around the world. Next slide. So advanced leak detection. And what exactly are we talking about? Well, advanced leak detection are the things that are being worked on today. The capabilities of determining methane leaks or natural gas leaks across the country, the sensitivity of those detection devices, what their capabilities are, the ability to monitor both wind direction and variations in GPS locations, so that nailing down exactly where the leak is originating from is now becoming part of the technology. Of course, we're talking about handheld devices, vehicle devices, drones, aircraft, and planes, and helicopters. Satellite fixed sensor devices are all part of this process. ALD finds more leaks on distribution systems. The advanced leak technology is capable of doing that. One survey that was done in 2 cities, they failed to find 65% of the leaks that advanced leak detection did find. And there were multiple grade 1 leaks in that discovery process. So some of this technology has a much greater sensitivity. Its capabilities in parts per million to parts per billion of methane molecules is much more advanced. For the industry, it becomes a question of how much does this cost, and what is it, how cost effective is it to put this into play. So next slide. One of the methods out there is computational pipeline monitoring. Let's not forget that the mandate put out by Congress on us in the industry, it addressed the elimination of hazardous leaks, and then it talked about the reduction of methane leaks. So the liquid folks are included in this process. The liquid folks need to look at how they're going to reduce the potential for hazardous leaks on liquid pipelines. One methodology in that regard is computational pipeline monitoring. Looking at the internal parts of the pipeline, looking at the conditions of the operating flow stream, flows, pressures, temperatures, density meters, flow meters, and the contributions and sensitivity of those devices, the location of those devices along the pipeline, how much telemetry do we have, and what capabilities do we have across segments of the pipeline to see changes in those pressures, temperatures, flows, and metered factors. Overshort calculations, that's exactly how it looks at the meter balance. It looks at the rate of change in the pipeline. It looks at the amount of material put into the pipeline and the amount coming out of the pipeline. And it compares those two and makes certain that they're equally balanced across the segment of line that's being measured. External systems include handheld sensors, permanent fixed sensor locations. Satellite technology is now out there. Vehicle and aerial technology, all of which have extremely advanced application and capabilities at looking at leaks on pipeline systems. Next slide. So what should the process be to establish an effective leak system? What is it you need to do? Number one, as Al mentioned, in these updates of your inspection and maintenance programs, you have to know your system operationally, under normal, abnormal conditions, under upper control limit, lower control limit conditions. What materials do you have in your pipeline? What is the history of leaks on your pipeline? What caused those leaks? What technology are you going to use to detect leaks? And where is it going to be located? How is it going to be installed? Is it going to be internal to the pipe stream like we talked about in the computational pipeline monitoring system? Is it going to be external? Is it going to be something that's buried along with a pipeline? Are we going to look at the high risk areas across our pipeline? Areas where if we do have a leak, it's going to be of a significant impact, opposed to an area where it's not environmentally, it's always going to be an impact, but it may be a lesser degree to the people and the property in the area. Making sure we configure the system to operate within the limits of the pipeline system. What are the capabilities? And how will it be commissioned? What data is going to be gathered once it is commissioned and operational? And what are you going to do with that data? How are you going to use that data to tune the system, to tune out some of the errant information that's maybe present, some of the false information that may be present, and turn it into a more effective system. And then, of course, I capitalize training, because if I don't have trained personnel to use these leak detection systems, they're going to be of little benefit to me. I have to have people out there that know what they're looking for and know how the equipment works and know how to use that equipment, what data they capture, and what they're going to do with that data. Next slide. So PHMSA has made it known that an operator, both transmission and distribution operators, have to have an effective integrity management program on their pipeline. So we're talking about transmission integrity management and distribution integrity management. And as a matter of risk being a leading cause of releases, third-party damage, line locating has moved to the forefront of their attention. Not long back, we attended a meeting with NAPSR and listened to PHMSA talk to some of the NAPSR folks and expressed the idea that it ought to be looked at as to whether or not an operator is measuring the effectiveness of their line locating processes. Are they getting a good result from the folks that are out there, boots on the ground, doing the work? Are locator personnel properly trained, and are they following that procedure, monitoring that condition? Do you know whether or not those folks that are going out there locating your pipeline are doing an effective job of it? Are they following your processes and procedures? Are they using your methodologies and doing them correctly? And if they're not, are you tracking whether or not their performance needs to be assessed? You have OQ qualifications for that task, and there are points at which the performance of that task comes into question, and whether or not a person gets disqualified has to go through a training program and become requalified. The second half of that naturally becomes, if they did not do an effective job on a particular locate and something happened, how many other of those locates did they do before it was discovered? And should you track that? So how do you know? Do you know whether or not it's occurring like it's supposed to? Do you know for certain that that work is taking place? Next slide. Leak survey, of course, is a methodology used, and it's a requirement of the regulation. What are your resources for doing leak surveys? Is it something you're doing internally? Do you have contractors doing it? What equipment are you using? Are you walking the right of way with your leak detection equipment? Are you driving it? Are you flying it? Is the answer yes to all of those? What equipment or calibration or replacement intervals do you have for that equipment? Is it being tracked and monitored and being maintained properly? Data tracking for risk assessments. For those areas where you do find leaks, how are you using that data in your risk assessments for your pipeline? Your leak classifications that Al mentioned earlier, are you looking at that based on what the regulations require? Or are you considering possibly accelerating that effort, moving it up on the list as to when things get repaired? I know there are operators out there that I've been in meetings with who simply make it certain that they repair all leaks. They don't use a classification system. They find a leak, they fix it. Of course, that's all based on a company's capabilities and what they have in regards to being able to do that. If those things are done, if a proper leak survey is done, if we're using the proper information and materials and equipment, and we properly trained our personnel, those leaks will decline over time, either through repairs or replacements, right? And that's something that needs to be captured. That would be the overall effort of the mandate from Congress, to make certain that we are reducing leaks in the pipeline, both those that are, normally occurring to those that are continuously occurring. Next slide. So some statistical information from PHMSA. In 2020, there were several thousand leaks repaired, right? 509,000, of which under leak classification, 196,000 were hazardous, and 132,000 were scheduled for repair. Of those, 78% of those total were on service lines, which is probably the lowest level of release rate. But with that number, 78% of 509, that's a lot of leaks. That's a lot of methane over time. So it's a collaborative effort across the industry. It's not something that's going to occur with one operator or another. It's something that all the operators are going to be looked at for making this reduction in methane release. Next slide. Transmission lines serve, they have a little better set of numbers associated with their repaired leaks from transmission regulated gathering and leaks that were scheduled for repair on the tube. The numbers are smaller, but of course we're operating at much higher pressures, so the total amount of methane being released into the atmosphere is what's being looked at, not necessarily the number of leaks. It's what the important part. 888 of those 1,686 leaks were equipment failure. So that's an area that has to be looked at. What equipment is failing? Is it valve packing? Is it some other component on the pipeline? Is it flange gasket repairs? Is it connection points, tubing connection points? I don't know. Whatever those others are the things that are being looked at very heavily. Equipment failure. Next. And the measurement factor that's out there for 2021 transmission leak sources looks at this in a kiloton of methane number. So the largest number in the list of kilotons of methane is compressor station fugitives. These are all the devices within the compressor station that are emitting natural gas, right? 681 kilotons of methane into the atmosphere. Of that, almost half of that is exhaust out of the compressor. So for those of you who have transmission operations and compressor station operations, are you looking at possible methane capture on the exhaust of those compressors? Pipeline venting contributes a large number. Almost a third of that total number comes out to be pipeline venting, maintenance, and upset. Standard practice out there a lot of times is just to blow the methane into the atmosphere, to blow down a line. Need to look at how you're going to do that in the future. That's part of the reasoning behind the congressional mandate, is to adjusting your inspection and maintenance practices to reduce leaks, to reduce the emissions of methane. Of course, station venting and of course pneumatic devices, a very small number in the total, but still a significant contributor to the methane release around the transmission line sources. Pneumatic devices, we know those devices powered by natural gas on the pipeline that are putting out a natural gas stream 24 hours a day, 7 days a week, right? And is there an alternative to doing that? Is there another way? So let's look at the next slide. So what do I do? To meet the deadline for the Pipes Act, you got to do that by December 27th. I think Al and I have probably hit on that enough times now that we've got that number in your head, hopefully. You have to update those inspection and maintenance plans. They need to be specific to your operations, your pipeline components and materials. A strategic plan to implement the provisions of those plans. Where do these updated inspection and maintenance plans exist? They exist in your O&M manual and your inspection points throughout your regulated requirements. So once you put them in there, you got to do them. Now, PHMSA has not given us any guidance on this. There has been no publication whatsoever other than an advisory bulletin talking about basically the same thing that the Congressional Act says, but we know that PHMSA is going to establish timelines for the implementation and performance of these activities. Create the criteria for tracking the effectiveness of the plan. How are you going to measure your effectiveness at reducing leaks and methane releases? How are you going to implement it? How are you going to document the results of that plan? And then measuring that effectiveness, making certain that you understand how well it's working. If your numbers are going down, granted, it's working, but what are you measuring to determine that? With that effort, you're also going to look at whatever deficiencies you may have, adjust the plan based on those deficiencies, and then start over, go back to the implementation step and document the results and measure the effectiveness and continue that closed loop over time. Being able to report out then to the government that you've been an effective player in this work and you have been able to reduce methane emissions. Next slide. And that, folks, is it. Unless you have any questions, we'd certainly like to hear from you.
Thanks, Wally. Okay, we do have a couple questions. My camera doesn't seem to be working. Sorry, guys. Are operators required to repair all leaks immediately on their system based on the new regulation?
No, so that's not the intent of the regulation. The intent of the regulation is to get operators to take an objective look at their system and determine where the leaks are and develop a plan to minimize their leaks. As we mentioned before, operators should be, evaluating the specificities of their system. If you are, say, a small LDC and you don't have a ton of services, and it's feasible for you to repair leaks in a rapid manner when you find them, and you can do that, you have the capability to do that, then that's great, right? That meets the intent of the regulation, that meets, what Congress is trying to achieve. If you're a larger operator with a ton of mileage and you don't have the capacity to repair things immediately, then that's okay. But you should still have a plan. Your procedure should still evaluate how you're repairing these leaks, and operators, should be aggressive to the limits of their capability to, find their leaks, repair their leaks, and minimize these releases into the environment.
Okay. Says, what criteria would an operator be expected to include in measuring line locating effectiveness?
So, of course, you would want to look at your actual procedures and your OQ qualification for a line locator. What do you require them to do? And you would want to measure that. Probably one of the better ways to do that would be to actually go out and look and observe and watch a locator do their job. Did they get it done within the time frame that the ticket required? Did they accurately locate the pipeline? Did they use the proper documentation that you provide, maps, alignment sheets, etc., to locate the actual pipeline? Were they effective in doing their job? The end result of the criteria would be, did they get the locate done correctly? And if not, if they had a problem locating the line, if they weren't able to make an accurate locate, did they notify the proper personnel? Did they respond back to you and make certain that you were aware of the problem that may exist?
Okay. How does measuring line locating effectiveness factor into leak detection?
Well, again, that's going to be a part of the damages that occur when proper locating isn't done. One of the most terrible things that can happen out there is for a third-party damage to occur that doesn't immediately get detected. A line gets snagged by a backhoe, a damage occurs on the surface of the pipe, and sometime later on that damage moves itself into a failure condition where we have a release that occurs. All the work's been done, the grass is growing back on the ground again, but the damage occurred some time ago, and now I have a failure and I have a line explode or I have a house blow up. But at the same time, I've got methane being released into the atmosphere the entire time that leak exists.
Okay. So
I think one of the biggest things operators can do, sorry, Marissa.
No, you're good.
I think one of the biggest things operators can do is make this as objective as possible. Utilize the data that you have, come up with ways to capture data of where your leaks are, how fast you're repairing them. If you can estimate how much methane is being released, but let the data drive you to make these decisions. Don't just make these decisions in a vacuum subjectively. Allow your procedures to work the way they're supposed to work. Allow your system to work the way it's supposed to work, and let that data drive you towards, where it's supposed to be. If you notice that these leaks are coming from valves, well, then maybe that requires you to update your valve procedure to inspect valves more frequently. But that's the whole basis of updating these plans and procedures, is to take some stance of objectivity on how to address these leaks. Sorry.
I see we have multiple questions online as well.
Yeah, I've got. Does the compressor venting also include the venting in an emergency ESD activation?
Yes. Yes. The mandate doesn't specify what type of leak it is. If it's a release, it's a release. Operators should have an idea of kind of what the release volumes for their emergency release device, their safety devices are. It's not meant to be perfect. It's not possible to capture everything, but the intent is to try to capture it as best we can. So you should be looking at, what's the possibility of having a release, and if you did have a release, was it measurable, and capturing that data to include.
Yeah, I agree, Al, and I would go along with that with the data that you do have. If we're talking about venting in an emergency or an ESD activation, so venting in an emergency is kind of a wild card. What's the emergency, right? And capturing that data is a little difficult. Emergencies vary from one condition to another. ESD of a station or ESD of a line segment, those are pretty predictable. Not the matter of the emergency shutdown, but the matter of how much methane is going to be released when that happens. And I would suggest that you look at that, do a good analysis of the ESD system and determine, is there any way to reduce the amount of methane that actually gets released into the atmosphere under a circumstance like that? How quickly do things operate? Maybe the logistics of the equipment and how it releases the gas could be taken into consideration. Again, like Al said, it's not an exact science here, folks. It's never going to be a situation where everything is removed. I think, but one of the things that has to happen is you have to be able to demonstrate a concerted effort to make a difference.
Okay, it says, many air pollution control districts in California have had fugitive emission programs for many years. How does this relate to the new regs and the plans needed by December?
Okay, so first off, there aren't any new regulations at this point. We have a self-executing mandate issued by Congress inside of the Pipeline Safety Act. So it became self-executing. It meant every operator out there operating in natural gas or hazardous liquid or LNG or underground natural gas storage facility had to comply with what it stated. PHMSA will issue regulations on this topic going forward. They have to. Because they're also mandated on inspecting all of these modified inspection and maintenance programs in the next year. So in 2022, they're required to complete their inspections of those programs and report up to Congress in the following year the results. So now how does that coordinate to your state efforts? Well, it would be the same as any other state mandated requirement for an operator that meets or exceeds the federal requirements, right? So they would be in concert with each other. I would suggest that an operator look closely, especially the folks out there in California who are managing this effort, look closely at what you're currently doing and what processes and procedures you have in place, and own those for this requirement inside of the pipeline safety regulation in the Pipeline Safety Act. Can't hear you, Marissa.
My bad, was on mute. It says, do these requirements only pertain to methane gases, or does it include all regulated gases like hydrogen?
So it's not, the mandate says leaks. As Wally discussed, methane is the primary gas that's being evaluated, but there has been no guidance that says otherwise. So operators should be evaluating any leak on their system, whether it's hydrogen, methane, natural gas, any type of regulated gas should be evaluated, should be considered under this mandate.
Okay. Are there any estimates for unregulated gathering, number of events, or total released methane?
None that I'm aware of. I'm sure they're there. I'm sure there's some agencies out there monitoring those conditions, but nothing that was been reported up by PHMSA, naturally, because PHMSA wouldn't have that data at this point in time. I would fully expect to see in any modified regulatory authority for this topic to include requests for data on that information. But at this point in time, I don't know that. I haven't seen any notice of proposed rule or anything else. I'm just speculating on how things go normally when these rule mandates come out.
Would targeted replacement programs to eliminate systems prone to leakage be something that we could take credit for in our amended procedures?
Can you repeat that one more time, Marissa?
It says, would targeted replacement programs to eliminate systems prone to leakage be something that we could take credit for in our amended procedures?
Yes, as long as it's a documented procedure, absolutely. I mean, if it's something that addresses the mandate, something that addresses leak elimination and reduction of leaks, that's absolutely something you can take credit for. It should be documented. You should have records developed for it. It should be like any other process or procedure in your O&M manual. And you can use that as a basis for fulfilling this mandate. Now, it should be ingrained into your overall O&M and other relevant procedures. It shouldn't, you shouldn't have it as a standalone. It should be something that's continued. It's not just a one and done type of a thing. It's hey, this is going to be a long-term process. And so having a targeted program is a great start. You take that and then you just expand upon that into your O&M manual and your processes.
Okay. How is the term pipeline defined? Are terminals and LNG terminals included?
Yes. So pipeline is defined in the Code of Federal Regulations in a variety of areas. But pipeline facility, this mandate includes and it specifies natural gas, hazardous liquid terminals in the sense of underground storage facilities, LNG facilities, wherever these natural gas, quote, natural gas facilities exist that are fall underneath the requirements of the Department of Transportation Office of Pipeline Safety. So the answer to your question is pipeline is defined within the Code of Federal Regulations in 191, 192, 195. But specifically, yes, it does address terminals, LNG facilities, and underground natural gas storage facilities.
How will the regulators audit and verify the data recorded by the operator?
So to this point, again, like Wally said, PHMSA hasn't put out any guidance on how they plan to evaluate operators. The mandate was put out by Congress. PHMSA put out an advisory bulletin, again, like Wally said, basically restating what was in the mandate. We expect to see some sort of guidance from PHMSA on how they plan to look at these, whether it's as part of a normal inspection cycle or if they plan to do focused inspections. There hasn't been a whole lot of chatter, a whole lot of guidance from PHMSA, direction that they want to go in, but we anticipate in the next few months, especially with the end date of December of this year for completion of this by the operators, that PHMSA will have put out a little bit of guidance as far as how they plan to execute their side of the mandate and as far as inspecting these manual updates.
Okay. How do codes and standards fit into new leak detection technology when codes are outdated?
PHMSA's always been open to the use of alternate technology. Alternate technology has been sprinkled throughout the regulations to perform this work. Now, again, the mandate doesn't say how you have to do it. If you have a technology that you use, if you have a system that you use that's proven, again, I go back to objectively. Can you objectively show that you're meeting the requirements of this mandate? If you have that system in place, if you have that technology, you can show that to PHMSA and say, hey, this is what we're doing. This is how we're capturing this data. This is how we're improving our system to minimize these leaks. PHMSA is always open to having that discussion, to incorporating new technologies. I mean, you look at the regulations and how they've developed over the years. Don't discount what you're doing just because it's not included in the regulation. If codes and standards will always outpace the code. The code will always drag behind industry. Industry always, is ahead of where the regulators are. And it's just the nature of the beast. So, if you're using a technology and it works and it's great and you can prove it, all the better. PHMSA hasn't said no to anything yet as in this arena. They haven't really said anything at all based on this mandate. So don't limit yourselves to what you can do. Just make sure that you're documenting what you're doing. Make sure that you can show that what you're doing is effective and efficient, and that it's been included into your plans. And like I said before, as this thing continues to roll on forward, we'll probably see a little bit more focus as far as what PHMSA is looking for and what they'll accept.
Okay. Says, doesn't DEMP already cover virtually all the things mentioned today? DEMP requires an effective leak management program.
Yes, it does. You're absolutely correct. DEMP does, so does TEMP, right? Leak detection, leak monitoring, leak repair has always been a part of the regulation. But what you see is Congress placing an additional emphasis upon modifying your inspection and maintenance programs to reduce that number of leaks. So yes, I think what you're seeing is, so if we look at the timeline and we look at the things that the Act put out, the Act said that these things had to be done, and it gave a deadline for operators to do that, December 27th, 2001. It also gave a deadline to PHMSA to monitor whether or not your updates have been done correctly. Now, did it give PHMSA any guidance on how to do that? No. Of course, them being regulators, they fully expected to develop regulation to help you comply with this requirement. They really are behind the 8 ball on this thing, like the rest of us. They've got, if you understand how long it takes to publish a new regulation, and at the same time, they're now mandated to go out and inspect to these Pipeline Safety Act requirements with no more guidance than you have. So to determine what is effective, this much I would say, you want to follow what the Act requires. You want to look at the advisory bulletin that PHMSA put out there and look at what the content of the advisory bulletin is, and discern from that you are needing to update your inspection and maintenance plans. Get that done. Look at your DEMP program, look at your TEMP program, determine whether or not there are things you can do to increase the effectiveness of that work. If you have a very comprehensive program to date, point to that and say, this is it. And I think that could possibly be an answer for some folks if you have a good comprehensive distribution program. But I think the vast majority of us could look at our programs and say, we could really improve here, we could improve here if we did these things. And that's what they're looking for.
Yeah, exactly, Wally. I think the whole point of the mandate was Congress challenging PHMSA to challenge the operators to get better, right? Everybody has their leak detection programs. Everybody has, goals to, hey, man, we don't want to lose product, and nobody wants to lose gas. Nobody wants to harm the environment. But, in this day and age with the increased visibility, the increased scrutiny over everything, it's, can we get better at what we're doing, right? And if you have that robust program and you can show, again, you go back to the objective data, if you can show the metrics that, hey, we're really good at what we do, you may not have to do anything at all, like Wally said. But I would imagine that most people can probably look at this and say, yeah, we can probably get better at certain areas. We can probably get better at, maybe some of these leaks that we're finding, we can repair them in 3 months instead of 6 months. Or, maybe we can get better at like Wally said, we can get better at line locating and have a more effective leak detection program and a more effective leak survey program. So again, it's not saying that people aren't doing what they're supposed to be doing. It's saying, hey, can you get better at it? Can you achieve more? Can you be more efficient with your leak detection, your leak survey, and your leak repair programs?
Okay. Do you see an increase in monitoring excavations to reduce damages not reported to operators?
An increase in monitoring excavations. That would certainly be a way to help reduce third-party damage. I don't know that. That's a possibility. I mean, an operator would certainly want to look at the number of times that they've had third-party damage occur. They want to look at the growth in the area that their pipelines exist. They want to look at the opportunity for, expansion in distribution, expansion of subdivisions, new building programs, new developments going on. Now, is that going to increase the opportunity for someone to stick something in the ground and hit my pipeline? And in that case, how many times in my area have I had third-party damage occur? And if that number is up there, then maybe I'll want to start going out and actually looking at the work that's taking place and making sure that the locators did their job and the excavators on the job are making proper monitoring. The folks monitoring the excavators are doing proper identification of the pipeline facility and other utilities in the ground to make sure things don't happen. So the answer to the question would be yes. I think they should increase. That would be a part of this process in your inspection and maintenance program. Will it? I don't know. We'll have to leave that up to the industry to decide which way it's going to go.
Okay. Says, can you separate what is actually required by Section 114 and the enforceability of ADB content?
I don't think we can until we see what guidance PHMSA puts out. You know, the mandate is straightforward, but it's very broad. I mean, it says you have to update your plans and procedures. It doesn't say how, like Wally said, it doesn't say how, it doesn't say, you know, much else other than that. And until PHMSA comes up with a way to actually look at that objectively, look at that, you know, from an inspection standpoint, I don't know if you can. I don't know, Wally, do you have an opinion on this?
Yeah, so what's required by the section? Ultimately, eliminate hazardous leaks and reduce the number of leaks, right? That's basically what's required. And they want you to do that by modifying your inspection and maintenance program. So what's actually required is a set of procedures written into your system that says we are going to do these things to help alleviate some of these problems. Enforceability of the advisory bulletin, of course, we all know that's not enforceable. That is guidance given by PHMSA in an effort to help explain Section 114. So what did they ask you to do? They want you to look at your facilities. They made it pretty clear in the advisory bulletin that your changes to your programs should look at the pipeline facilities that you have. What materials do you have in the ground? What is the history that you have? Someone mentioned earlier that there are some pretty comprehensive DIMP programs out there. Well, if there are, then you have good data that says we have this material in the ground, this vintage pipe in the ground, this type of plastic in the ground, these situations. One of the factors that's out there that Al mentioned earlier is cast iron. Cast iron's been a leaking program for years. We've had cast iron remediation programs across the country. Some of those programs have taken a very long time, understandably, but where they're located, getting in the ground to move them, getting in the ground to change them and continue service to thousands of customers is not an easy task. Getting permits to make that work take place takes time, a lot of expense involved. It'd be nice if the natural gas industry could go out there and do all of these things without concern for dollars, but then the majority of our customers wouldn't be able to afford the gas either. So it's a balancing act. So what is enforceable? The act itself, the Section 114 itself says you have to update your inspection and maintenance plans. You need to be able to demonstrate starting January 1, 2022, that you have updated inspection and maintenance plans. That's as far as I can go with any details. Looking at your individual programs, I can certainly help you do that, but and give more insight to it. But in a generalized statement, it would have to be that way.
Okay. How is this going to apply to hazardous liquids?
Keep it in the pipe. That's, you know, there's no leak classifications for hazardous liquids, right?
I mean, liquids have to get fixed.
Yeah, you got a leak, you fix it. Again, looking at your data, looking at your pipe, looking at your history of leaks, looking at the things that have caused the stuff to come out of the pipe, advancing a program that's going to help focus on that and eliminate the possibilities for those things to happen.
Cool. All right, I think that is all the questions we have. Those were great questions. That's all the time we have for today. We hope you all enjoyed the presentations. If you think of questions later on, feel free to shoot me an email and I'll pass it along to Alan Wally, or I think Alan Wally's info is on this presentation that you'll be getting in an email here in a little bit, so you can reach out to them directly. We hope you have a great rest of your day, and we hope to see you back next time. Thanks for joining.